Adaptive thresholding. So here, basically, while the simple thresholding is a powerful algorithm, it has its limits, such as when there is uneven lighting in an image. This is where the adaptive threshold comes to the rescue. This is technique that can increase the versatility of image thresholding operations. Instead of taking a simple global value as a threshold comparison, adaptive thresholding will look into its local neighborhood of the image to determine whether a relative threshold. Start the code typing by mg cv2.mread, and here we have the game.png file inside in it with 0 to show us that is a black and white image, and cv2.mshow the original one, and here the mg. Just we need to write here at the end cv2.wait key pass 0 cv2.destroy all windows, and here just we need to call the ret and thresh like last time we have done this. Threshold basic is equal to cv2.threshold, the built-in function here, and img. We are just passing the 70 and 255 value here. 70 as a threshold value as a guess, and then the maximum value 255 on-site integer, and then we will type the cv2 here, the cv2.thresh underscore binary in capitals, and now we can show the results here with cv2.mshow, and here the basic binary, and we can pass through the thresh basic here. Okay, now just needs to run this code and see the results. Python 303.py. If you see here, this is the basic, this one is the original image, and this one is the basic binary. So we can see the few problems in the top corner of this image, if you see, and we can see that we have some of the images of numbers coming through, but it is bottom left hand corner, it's already being blocked. But because of the dark image, if we are for example want to maintain all the lines and the game's layout, we would not be able to do this with this image. Therefore also you can, and we have to look to use the adaptive thresholding here. So pressing the escape and just moving to the code base here, and just we need to write here the thresh and adapt is equal to cv2.adaptive threshold, that is the built-in function, and we will pass the image 255, the maximum value cv2 dot, and here we are just calling the method adaptive adaptive threshold Gaussian, spelled basically the GAUSSIAN. That is basically underscore C, which will be the needs to use here like this. And also we need to again followed by pass the CV2 dot thresh binary. Again, this thresh binary we need to use here as well, and then you need to pass the values to it from 115 to 1. So basically neighborhood parameter indicating how far or what the localization or whether the adaptive thresholding will act over this value, which we have already put it 115 and then value 1, and which means subtraction from the end result. Just put through here, just escape it, just ensure. So basically we need to show that image as well here. Ensure the adaptive thresholds and thresh adapt. So now we just needs to run the code and see. Basically we are not used this not shown the image previously, so here the adaptive threshold is here, and you guys can see the results. And here there's still some artifacts noting there is a little speckles here and there, but it's actually something we can utilize the dilation and erosion functions for if we really need it. Nonetheless, adaptive thresholding can be a very useful algorithm for segmenting out exactly what you need to image, and despite the uneven lighting or the other artifacts. So here there's the clarity in it by this. Thanks. I'll be back with next lecture.